Yeah, this is in the area of partnerships, so I wanted to I'm in the lab, so my main focus is generating quality lab work, but I wanted to try to, so a lot of these are going to be about the lab functions and what we do there, but I wanted to try to blend it with partnerships that we have with our groundwater section and some other people that we work with. So hence the title of my talk, Public Service Partnership Supporting Well Owners in Illinois. So yeah, I just wanted to give a brief slide here. The water survey has been in existence since about 1895. It started here at the University of Illinois. They were tracking typhoid, I believe, and they noticed a trend, relationship between water quality and these families with disease. There used to be a nice dedication sign up at Noyes Lab. That's where the water survey had started, in the basement of Noyes Lab. So they had a nice sign up there. I think the last time I checked, it was just a pole. So I'm not sure what's going on with that. But anyway, we've analyzed a couple 100,000 samples since 1895. And since then, the water survey's branched out onto many other areas, atmospheric, basically all the water cycle you think of it. So there's a lot of other research going on with the water survey. The public services that we have with my lab and the groundwater section, those are still part of our mission. It's tax-supported functions. So yeah, I wanted to focus on three areas today. The assistance we provide with these functions. In our laboratory, we test the water, but it often starts with people, they'll call into the lab first, and we'll try to answer a lot of their questions, as many as we can. Sometimes it doesn't require any testing. They just want to know how to interpret some other results. They want to know just some good practices with their well ownership is. Or they might have questions I have to direct off to the groundwater section. But then if it does end up requiring water testing, we do offer a lab analysis of water, so that's what several of my slides are going to be. We don't do any bacteria testing. There's a lot of discussion of that today. Our focus is on sort of an overall mineral content of the water, and we also offer lead testing. It's an additional charge. And then the third thing I mentioned here is the groundwater information section. That's part of what Steve works in. And they have a lot of records that go back, just like we go back to the foundation of the water survey, the groundwater section does too. So yeah, I mentioned we don't do any coliform testing, but I'll go into several slides here. What we do test for, arsenic and nitrate are a couple of big ones. Those will be in some future slides. It's like I mentioned before, I think I mentioned it, it was tax supported. It used to be free, so that was really a nice feature up until around 2011. When we started, they said, well, budget cuts, and everybody's familiar with that. So we started charging small fees to cover the mailing of the bottles themselves, things like that. It'd be a good time to mention here, generally how this process works. We have customers, we try to get the word out, and then mostly it's word of mouth or through health departments, things like that. So they'll call in and we will mail out a kit. It's got a little refrigerant pack in it. Then the customers will mail this back to us, and we do the testing here in our lab in Champaign. And then we will, after about a month or so, month to 6 weeks, maybe a couple weeks for lead, we will send out a letter in the mail. Sometimes we're moving to some people who want it by email. And I guess I'll start into some of the testing that we do provide. Like I said before, it's a mineral analysis. It covers about 35 elements. It's pretty comprehensive. It's only for private well owners in Illinois, not municipal customers. But lead is something that we have offered, lead testing for any customer in Illinois. We'll send out two bottles, a flush and unflushed bottle. I guess there's our website there. That's probably the primary contact. It's not a fancy website, but it has some basic information. It has some links that I will use a lot for well customers. In Illinois, the Illinois EPA has a drinking water watch. We get a lot of questions about municipal water. So I'd like to refer people to that. There's some other links to other Illinois Health Department website, Illinois EPA, consumer confidence reports on a national level. So I thought it would be, in pointing out some of the things that we do, I thought I'd just show some typical examples of the levels we see. I just chose a sample here that was fairly representative of hard water. I would say normally iron is there too. In this particular example, iron's not there, but these are some of the primary metals that we test for: iron, potassium, calcium, magnesium, sodium. Those are some fairly typical levels there. It's hard water. Like say, iron, we do usually see iron in probably 95% of our samples at somewhere between 2 and 10 parts per million. Then we moved on to some of the more trace metals. Arsenic's in here. We've had a lot of talk about arsenic today, and that's also, I've got a couple slides on arsenic. These things are just part of what we can get off of our ICP instrument. I can list them here: aluminum, arsenic, barium, beryllium, boron, chromium, cobalt, copper, and lithium. And then there's another page of these. Manganese, molybdenum, nickel, strontium, tin, titanium, vanadium, and zinc. Then we have the anions part: fluoride, chloride, nitrate, phosphorus, sulfate, and bromide. Those are typically by ion chromatography. And then we have, sort of to finalize it, we have just miscellaneous, what I'll call our miscellaneous analytes. Turbidity, mostly that's iron precipitation. Color, typically a measure of tannins is what we typically associate it with. That's at the bottom there. We have another thing that can measure non-volatile organic carbon. So the organic carbon typically ties in with the tannins. Then we do a pH in the lab. This is all done in our lab here in Champaign. A pH and alkalinity titration, a hardness calculation, silica, and total dissolved solids measurement. You guys are all used to this. We make our comparisons, try to choose something objective to compare to, so we choose the USEPA National Primary Drinking Water Regulations and the Secondary Drinking Water Standards. The Illinois Department of Public Health has some nice guidelines out there, so we look at those too. Some of our scientists have developed some arsenic resources, and so we've make reference to that for some of these things too. We've tried to, we send out a letter, but just as a lot of you guys have mentioned today, sometimes it's hard to get people to understand exactly what an analysis report looks like. So we tried to make sort of a summary. It's not like this is anything new. This is information that's just taken from these websites, the Department of Public Health or EPA websites. We've just tried to put it into a nice summary like you might get from a medical test. So here's a sheet with things that you can kind of get a little bit of information on. It's double-sided. We'll send that out along with our sample summary. It comes in the form of a letter. We're trying to make it easy for customers to read, try to relate to customers. So instead of just giving a lab report, we'll send this information sheet, and then we'll also send a letter that will basically say, for this sample, it'll say, hey, the sample was classified as very hard. It had, in this particular case, iron and manganese levels were low. The total dissolved solids were a little bit high. There was no nitrate and arsenic detected. So nitrate and arsenic are probably our primary things that people will be interested in, or they'll make the news. But dissolved solids comes up fairly frequently, as do other things. We can test raw water. That's we require a raw water test, but we also offer a service that I like to promote, because a lot of our customers will say, hey, I don't really care too much about the raw water. I want to know what I'm drinking. So we, if they submit us a raw water sample, we'll also test their softened water, or a lot of times they'll have a third treatment like a reverse osmosis system. So part of the stuff we send out, for a little bit more, they can just, basically the initial cost is $35, and for $15 more, they can get these other sources tested. And so I thought I'd show on here, you guys are probably, most of you are familiar with some of the levels that you might expect after a softener or a reverse osmosis unit. But I thought it might be nice to show this a little bit for anybody who was unfamiliar with that. This looks like a different water sample than I just touched on. It has a fairly typical iron level. It's hard water. It's got calcium, magnesium there. Arsenic's getting close to the limit in this sample. Let's see, we're trying to look at other things that I might point out here. The rest of these are fairly typical typical levels. You can see the soft water. We often talk about calcium, magnesium in the softener. I think I've got that highlighted here. But let's look at the primary analytes. Calcium and magnesium are typically removed with softeners, so you can see the hardness calculates to very low. Sodium, you guys are all probably already know this. Sodium increases with the softener unless you have a potassium-based regeneration. But most softeners will also take out iron and some of these other elements. Barium, manganese, strontium, and zinc, all pretty effectively removed with this person's softener. Sometimes we do find that the iron is not really effectively removed, and then they might turn to other, especially if the iron gets, like, say, above 5 or 10 parts per million, then I think customers will usually install something else. Let's see. Oh, yeah, I wanted to point out the arsenic here. Softeners don't typically remove the arsenic. I think sometimes we've seen some samples that will come through, and the treated samples will have a reduced arsenic concentration. I think that's usually associated with co-precipitation with iron. But in this guy's example is fairly typical. The arsenic is not changing after the softener. The reverse osmosis, I think, is next here. This is a case just where there's some problems with the reverse osmosis. We see mixed luck. There's a slide on this later. Mixed luck with reverse osmosis on arsenic treatment. But in this case, you can tell if you compare, like, say, the sodium here after the reverse osmosis is a little bit elevated than the softener, and so are several of these other minor elements. And so that just tells me that the reverse osmosis is not working. So this customer may have asked about that initially, or they may not have known. They just all kinds of situations come up. I'm sure many of you guys have experienced similar things. This is the same customer. The primary thing we use to judge the reverse osmosis effectiveness is the dissolved solids. And so it's really easy to tell here that there's a problem. Basically, it's not working at all. I'm not sure I have an explanation for it adding things, but it seems to be adding a little bit. Let's see, what was I going to point out here? I think just some other typical values. These things are not typically changed by the softener. The turbidity goes down typically because the iron is removed. And most of these other things don't change when you have a softener. So that was the first example. It was just sort of a fairly typical one. Then I have a couple of examples in here with some of our customers. They'll call in with specific questions. Well, all of our customers call in with a question. Often it's just, hey, I saw an article about water testing. I thought I'd get my water tested. Sometimes people will say, I've never had it tested. Whatever. Some people will actually have specific concerns. So this was an interesting case where we had somebody was just, usually we can't help these people, it's kind of ambiguous. In this case, it was interesting because she called in specifically about arsenic, and they had found some, I don't know if it was a hair test or a blood test, but she was trying to find the source of arsenic, and they were, I think, running out of options. So somebody said, hey, why don't you look at your water? And so we tested their raw and their soft water. And I thought I'd put some of the results on here. This was back in February of last year. This particular person, if you look down there, she had fairly typical iron concentrations and the hardness, and many of the other things are fairly typical. Her arsenic was 154. I wouldn't say that's typical. That's on the high side. We do have, I think some other people have mentioned the amount of arsenic that people have seen. I would guess, this is unofficial, but maybe 10 to 20% of our samples have arsenic above the MCL. This one is much higher than the MCL. So she was right to be concerned. I guess let me see if I've got it highlighted here. Okay, there's the arsenic's highlighted. So another thing I notice on here that the organic carbon, I think, I'm not an expert at the research on this, but I think sometimes you'll see arsenic associated with organic carbon levels. Thanks for some agreement in the. She also has the dissolved solids here are fairly high. You know, an average is probably 400 in Illinois. That's kind of another unofficial number. But something like 570 is fairly typical. In this case, this customer actually had talked with us a lot and talked to some of our groundwater staff a lot, and she was, she was upset because she bought a home and she had this problem, and now she has to deal with it. A lot of times people will put in a point of use treatment unit. She wanted to cover the whole house because the arsenic level was so high. She gave us, I don't have the name of the device. We don't generally get into specifying brands or anything. But when I looked it up, the cost of the device itself for a whole house arsenic treatment unit was about $2,000. So that was fairly expensive. I mean, it's on scale of a good water softener. But she did install this device, and she retested her sample. She retested it actually a couple times. I'm just showing the final result here. The first time she retested it, it was like in the 30s. The second time she retested it, it came down a little bit farther. I think the company perhaps had advertised it'll take out all the arsenic, but if you read, if you look at their website, I think it said they will guarantee that it'll remove all the arsenic or a major portion of the arsenic. So depending on how you interpret that, I would say she has a good reduction. She had about 82% reduction in her arsenic concentration, but it was still above the MCL. So we recommended further treatment, like reverse osmosis, it may help. So that was interesting. It was, I haven't had any further follow-up, so I'm not sure if she finally got it under the limit or reduced down to 0, which would be optimal. Oh yeah, I guess I wanted to say some other notes about arsenic. A lot of you guys have probably touched on very similar things, or if you go out on the internet, you can look at, find similar information. We used to just say, put in a reverse osmosis unit and that'll take care of the arsenic. But what we're finding, and other people have found the same things, it can be very effective, but we've had people that have had 0 arsenic removal with a reverse osmosis unit. The effectiveness seems to be increased if you have some type of pre-oxidation. It has to do with the structure of the arsenic 3 versus arsenic 5 components. And they've generally found that the arsenic 5 is much easier to remove with a reverse osmosis. I tried to pick out some examples that might show some of this. Let me see if I've got these highlighted. There are a couple here. I think these are different customers that just one person happened to have some type of oxidizing filter and another person didn't, and they both had a softener followed by a reverse osmosis unit. So you can see some variation here. I've got highlighted the arsenic removal as compared to the total dissolved solids removal. Those total dissolved solids numbers are fairly typical for RO units, about 90%. Some of them aren't as effective as others, but you can see the people who've got some oxidation here have a arsenic removal fairly typical or fairly comparable to the TDS removal. Let's see what we have next. Some of our customers do follow some of the practices that people are discussing here today, like continue to test your water. So we have a fair number of people that will test it not every 3 years, but in this case was another 8 years later. And it was interesting that the arsenic was fairly consistent. That's actually much more consistent than I would have guessed, but similar to what Steve has said, we've seen results plus or minus about 10%. But in this case, his treatment was getting older. So he went from 77% removal to 9% removal. So it looks like he needed a membrane replacement or some type of service on his RO unit. Okay, and this one, was just meant to show that some people will have a filter. I don't think, I would have listed it here, but I think in this case they'll just say, hey, they've got a filter along with their softener, so it seems to be taking out some of the arsenic, and then they'll put a reverse osmosis unit after that. Some of these public service testing that we do or the discussions we have with our groundwater folks, that's going to be in here next. they'll lead to stories that make the paper. This was an interesting case a few years ago. This person's arsenic was 350 parts per billion. So that was, I think, the highest we'd ever seen. I don't know what the high in the state is, but this was interesting enough. And she was, I think, in an area where it was going to cost her a certain amount of money to get connected to the public water supply. So eventually she did do that, but this generated a lot of interest. And it kind of leads me into talking about how we've worked with our groundwater people and how they've interacted with other community resources to get the word out about arsenic or get the word out about testing your well water. The testing we did, I'm not sure if I mentioned it earlier, but there's a dual benefit. We can test water for citizens, but there's a benefit we get out of that too, and that it might lead to future research if we notice there's a lot of arsenic. So our groundwater folks can say, hey, let's go out and study the arsenic more in Tolona. We had the high arsenic value. Let's go out and see what other people have in neighboring wells. So in this case, there was a further study done by our groundwater scientists, and they actually had a town hall meeting to discuss some of the results. The other slide was kind of hard to read, so I blew up some of the wording there that kind of demonstrates the community involvement that our staff performs. This public meeting was held after they collected these samples. And I wasn't involved in any of this, but it does look, it was very nice to see that they worked with the local extension office to work with these citizens. That leads me into the other part of what I want to talk about is these other people that we work with. In addition to Steve, Walt, Kelly, Tom Holm, George Redcap are all some very good groundwater scientists, and that's another whole section we have at the Water Survey. And so I wanted to list their website here. It was relevant to arsenic. This picture here is Muhammad Aquifer. It's a main aquifer here in central Illinois. There are other aquifers I don't really want to get into the aquifers, that's their field. This sort of shows where the red squares here are greater than 50 parts per billion of arsenic. The blue dots are above the limit, 10 to 50. 50 is the old arsenic limit. I'm sure you guys know that. There are a lot of other resources, especially on arsenic, but there's a lot of groundwater resources at this website. In addition to arsenic, another partner I want to thank here is the Kay Shipman with the Illinois Farm Bureau. When she writes these newspaper articles, we do see a surge of sampling. And nitrate is another concern that people have. We found arsenic and nitrate very similar stories. Usually someone will call in, they'll say, hey, I've got infants in the household. Yeah, that's what this will say. She had an infant in the household. She wasn't really concerned about arsenic, but they were concerned about nitrate and lead. So I just put some of the relevant information up here. She didn't have any arsenic, although just like other people have said, you can't taste it. You would never know if you have it. And the interesting thing about arsenic is it can vary. It seems to be very localized. Sometimes you can go up the street. It might be in certain areas, but will be neighbors that might have 10 parts per billion, and then a few blocks down the road might be 100 parts per billion. In this case, we were talking about nitrate, and this person was right to be concerned. She did have a high nitrate level, but some other things that we let her know. The arsenic was low. We suggested follow-up. Because of the nitrate, we suggested follow-up testing with her county health department for bacteria testing or any other testing she might be interested in. We suggested she add water treatment like reverse osmosis. The lead is present, so there might be a concern, but it is less than the action level that's used for city supplies. If she's concerned, she should flush the water before using it. As you can see, after she flushed the water, there was no lead detected. And then, just a little bit more about our groundwater science section. We have a lot of groundwater records here. It's the state's primary repository. I think this is accurate. The state's primary repository of groundwater records and data. I know a lot of health departments, they have records. I think we get some of those records. I'm not 100% sure on exactly what we get. But this goes back to the founding of the Water Survey too. I think I touched on that earlier. And our scientists in the groundwater section, they work closely with other scientists within the Water Survey. We're part of the Prairie Research Institute here at the University of Illinois. the water survey started as a function of the University of Illinois. Then in 1910 or 1911, we were branched off into a state agency. We remained a state agency until a few years ago when we merged back into the University of Illinois due to state budget cuts, or the risk of those. Anyway, I guess here I wanted to talk about our relationship with our groundwater section. We are in different buildings, and it's a convenient relationship. It's beneficial to both of our groups because we have well owners will call in to either of our groups, and they'll have questions. I can't answer all the questions. I can try to do the testing and answer some water quality questions, but half the time they'll also have questions about miscellaneous issues about the hydrology, their well records mostly. A lot of times the issues can be complicated, so having this relationship with our groundwater section and having them be close to us and just a short walk to another building allows us to easily collaborate. It's beneficial to the well owners because we can develop better answers for the well owners, more complete answers. And it's similar, it sets it up to have us work, or anybody, it could be used as a model for anybody who could work with other agencies like health departments, geological surveys, or extension programs. Allows for a more comprehensive approach to supporting well owners. We do work, I've got some thank you slides in here. We do work with some health departments and some other agencies. Not sure if that's up yet. Okay, we'll get to that in a bit. Here's a bit more about our groundwater section. This is a picture of our records room. There's a lot of paper records here. And just some typical questions. This is very common. I moved into a house with a well. The previous owner didn't have any records. So do you guys have anything? Personally, I live on a well, and I found this very useful because I didn't have any information about the well, except that there was a well sticking out of the ground, a wellhead sticking out of the ground. And I was able to find records of my well and found it had a lead packer in it, but that was a different issue. Other questions we'll get. How deep is my well? What's the typical depth of wells in the area? Is groundwater available? There might be different aquifers, so one well might go down 100 feet, another in the same area, some other wells might go down 250 feet. They might tap into different aquifers. There might be some crossing between the aquifers. Those kind of questions I direct out to our groundwater people. A couple years ago, there was a drought here, and some people had said, I've been here 30 years, my well's never run dry. What do I do about it? Is this going to be expected in the future? Things like that. What's the water quality like in different parts of Illinois? It can vary. In the northern part of Illinois, it's a lot different than it is in southern Illinois. So we have those kind of questions, and I will direct those out to our groundwater scientists who are listed here. This cooperation is actually, our relationship has led to partnership with this organization here, the Private Well Class. So I wanted to give Steve a thank you for everything he's doing. It's a great program. Just some thank yous to some of the groups that we work with up in the northern counties of Illinois. It's the Barrington Area Council of Governments. I know that our groundwater scientists work with these guys, and we work with them on a regular basis. I think what they're trying to do here is get a pretty comprehensive idea of the water quality. I don't know how many wells they have up there. It covers a lot of counties, 1,000 wells or something like this. And they're trying to get all those wells sampled, so we're taking them in batches and doing so many at a time. They've got another lab they work with, or a couple other labs, I think, doing some coliform testing. We're their level 2 testing lab. So that's a pretty good example. They're good people to work with. But also we work with health departments around some health departments around the state. Cook County, we're doing some lead testing for them. Vermilion County, some of the ones that are closer around here, we tend to have more phone conversations with. Some of these health departments will just have links to our analysis or to our website, and that'll lead to other calls. Just sometimes it'll just be nuisance chemicals or nuisance. A lot of times it's just somebody's concerned about the black or brown staining, and they'll want to test and see if it's always iron or manganese. So here's some of the other health departments that have been helpful to our cause. So I want to give a thank you to all these guys. And other health departments, if you're here, talk to me afterwards. We can discuss, what we can do to help out. Other state agencies, Illinois Department of Public Health has a nice website. There's some other, the Illinois EPA and University of Illinois Extension. And I think the last one is just to Kay Shipman, and she's written a couple articles for us with the Illinois Farm Bureau. So I think that's it. And do we have questions?
Any questions for Dan?
All right. Thank you, Steve.
Thank you.